When we talk about the isotope composition of a sample, say of a meteorite, we typically mean the isotope ratio of this meteorite relative to the isotope ratio in a standard. This is how we measure and how we only can measure the isotope composition, the isotope ratio in a sample relative to the isotope ratio in a standard. Now, when we measure isotope ratios using a mass spectrometer, in particular in one technique, we already measure the sample directly against a standard. And this technique is then called the standard sample bracketing, and it is illustrated here. So here these yellow and blue things represent beakers or tubes that are filled with a solution, and this solution is then sucked into the mass spectrometer. In yellow there's the standard. The standard is always the same composition, and in blue there are 3 different samples, maybe 3 different meteorites. Now there's this white thingy going into the first beaker, sucking solution out of this first standard here and into the mass spectrometer. And then in the example of iron isotopes, there are 3 iron isotopes that I measure. This is iron 54, iron 56, and iron 57. And the abundance of the iron isotopes are measured using detectors, and the result is given as volts. And above this first beaker here, there is the result of the first measurement. So the solution is sucked out of the beaker and into the instrument, and then here's the result. So 54 iron is something like 0.8044131 volts. 56 iron is 13.4893946 volts, and so on. Then after this solution is sucked out and measured, the nozzle moves to, in this case, then the first sample. And then there's the result of the first sample, which is 54 iron, has an intensity of 0.7473989 volts, 56 iron 12.53, and so on volts. And then the nozzle moves to the next standard, sucks out the solution, measures the iron intensities again in volts, then moves to the next sample, measures the iron isotopes, the intensities of the iron isotopes to the next standard and to the next sample, and so on. So each sample here is bracketed by 2 yellow standards. Each blue sample is in between, bracketed by the 2 yellow standards. So last standard is measured, the last result is produced here, and this is how the analytical part of the sample standard bracketing works. So just measuring sample standard, and so on. Then these results are taken to actually calculate the isotope ratio. And this is done like here. So here I used 2 standard values that bracket 1 sample value. And these are again just the intensities. Then I use, for example, from this standard here, the 56 and the 54 iron, and divide these. As said, we calculate isotope ratios. And this is how the isotope ratio is calculated here. So I take the 56, the 13.48939. This is then the nominator, and divide it by 0.8044131 by 54 iron. This eliminates the unit volts, because it's volts divided by volts. And this is then produces a ratio of 16.769238. And I could do the same now for 57 iron. So dividing the 57, the 0.321, by 56, and then I would have the 57-54 ratio, which is normally done. I'm not doing it here, so there's not too much on the screen here. And then I make the same calculation for the sample. So divide the 54 by the 56 by the 54. This produces 16.7676964. And you can see already that there's only very small difference, as isotope differences are usually very small. So it's just in the 3rd digit after the point is a difference. And do the same for the next standard, and well, it's a standard, so it should give the exact same ratio as the first standard. It's not entirely the same as you can see here, but it's very close. So these are the standard values, the bracketing standard values, the above and the lower one. Now I take the results. So these are just the ratios that I just calculated from the first standard and from the second standard. And these should be the same, but they are not entirely. But this is what the machine produced, so one standard, second standard. So the real value, well, ideally the real value should be in between these two standard values. And this is why I produce a mean value. So I take the first standard and the second standard and make the mean. So I add these two, divide by 2, and then I get the mean value for these two standards. And then I use the equation for the delta notation, which is delta 56 iron divided by delta 54 iron is 56 iron divided by 54 iron in the sample. So this would be this ratio here, divided by the ratio in the standard, which I just calculated. So I put in the sample value is 16,76769, gets into the denominator, and the standard ratio gets into the denominator. And then I calculated it, and the result then is a delta 56 iron of minus 0.13 per mil. And this is how sample standard bracketing works, and this is how we calculate the delta value from the sample standard bracketing. And I could also, for the delta value here, write delta 5654, and I could also write down the standard I used, and the standard solution for iron, for example, is the IRMM014 standard, and I could add this here as well, and then I would have the complete result. And this is how standard sample bracketing works.